Hello. So we have given a disk of mass m and radius r. And we know the moment of inertia of the disk about this axis, which is passing through the center of mass and perpendicular to the plane of the disk, is half mr square. In this question, we have to calculate the moment of inertia of the same disk about one of the diameter. I'm calling it O2, axis I'm calling it O2. So I have to calculate moment of inertia about one of the diameter. And then we have to calculate moment of inertia about the axis which is perpendicular to the plane of the disk and passing through the periphery, which is O3. So I have to calculate about this axis and about this axis. Okay. So first we'll calculate moment of inertia about this one, using the moment of inertia which is given in this case. Okay. So let's make one more diagram. So we have given a disk, and the moment of inertia about this axis is known, and about this axis we have to calculate. So IO2 we have to calculate. Now let's go by the perpendicular axis theorem. If you know the perpendicular axis theorem, in that case the summation of, generally for the 2D bodies, which is, that is 2D bodies, if the moment of inertia of the body about two axes is known which are perpendicular, then the summation of those two will be the moment of inertia of the same body about the third axis which is perpendicular to the previous two. So what we will do, you see, since you can see the disk, in case of disk is symmetric. So I'll go for this axis. This is my first axis and this is my second axis. Both of these axes are diameter, not just these two. We can have n number of axes which will be along the diameter. Now if you see these two axes, with respect to these two axes, the body is same. Whether you see about this axis or you see about this axis, both of these axes are completely same. So on body is also, with respect to these two axes, the body is also same. Only thing which will change is the plane of rotation. Except that, everything will remain same. So let's assume the moment of inertia about this axis is I. Then moment of inertia about this axis will also be I, because it will be same due to the symmetry. So if you see, I'm calling this axis as X and I'm calling this axis as Y. So there will be this axis Z. So we know, according to perpendicular axis theorem, moment of inertia along x-axis plus moment of inertia of the body about y-axis is equals to moment of inertia of the body about z-axis for 2D body, which is the disk. So Ix is I, Iy is also I, which we have to calculate, and the Iz is given, that is equals to half m r square. So that makes moment of inertia I is equals to 1 by 4 m r square, and that is nothing but moment of inertia of the body about second axis. So you see, by using the perpendicular axis theorem, we have calculated the moment of inertia about this axis. Okay. Now let's go for calculating the moment of inertia about this axis. If I want to calculate the moment of inertia about this axis, I can use the parallel axis theorem. So parallel axis theorem. If you remember the parallel axis theorem, it is equals to I is equals to ICM plus m x square, where I is the moment of inertia about any axis, ICM is the moment of inertia about the axis which is passing through the center of mass, plus mx square, where x is the distance between those two axes. These two axes has to be the parallel one. That's the only condition there. So I'm having the disk, and the moment of inertia about this axis is known. If you think about the third axis, O3, third axis and this axis, they are parallel. Since these two axes are parallel, about one axis I know the moment of inertia, about the other axis we want to calculate the moment of inertia, and the distance between these two axes is, it's not x, it's r. So I can make the relationship. This we have to calculate. This is IO3 and this is IO1, but I'll call it ICM because this is the center of mass. Then according to parallel axis theorem, IO3 will be equals to ICM, which is half m r square plus m x square. In place of x, it is r square. That makes IO3 is equals to 3 by 2 m r square. So see, when we have given the question regarding calculating the moment of inertia, we have these two theorems. When we do calculate moment of inertia through the derivation, we can memorize some of the moment of inertia, but we cannot memorize all the moment of inertia. So with the use of memory plus these two theorems, we can calculate majority of moment of inertia. Basically, if I know this one, I can calculate. If I calculate about this diameter using the perpendicular axis theorem, then after using the parallel axis theorem, I can also calculate moment of inertia about this axis, isn't it? Or about some other axis. In between also I can choose the axis. It's not like we have to calculate only about this axis. If I want, I can calculate moment of inertia about this axis also. The distance, only the distance will change. In place of x, in place of r, it will be some r by 4 or r by 2 or just the x. We can calculate that. Okay? That's how we use parallel axis theorem and the perpendicular axis theorem. Thank you.